Welcome to the Bible and Science. This is Dave Prentice. I'm a retired public high school teacher, certified in all branches of science and math. I've also taught on the Bible and science for many years, both in the U.S. and on many overseas mission trips. This is episode 14 of the Bible and Science podcast. It will get into a few little technical things, so just hang on, and if you need to fast forward at those times, do so, but please, you may get something out of this. The questions here are, how is the universe developing in the present, and then in the past, how did it develop? That is it going from simple to complex or complex to simple? And then, how persuasive is the case for a Big Bang? Remember, I've brought this out before. Any model of origins has to deal with at least four major areas. Number one, how did matter and energy come into existence? We talked about that in the last session, and there is no natural explanation for how they could have come into existence from nothing. Well, number two, once matter and energy somehow came into existence, how did they get from the beginning conditions to the present state? That's most of what we're going to talk about tonight. And then how did life begin? And then once life began, how it got from there to its present state. That's going to be some future sessions. Okay, how did matter and energy come into existence? This was the subject of episode 13. In Genesis 1:1, God created the heavens and the earth. The Hebrew used was bara, and it's usually taken to mean creating from nothing. In Genesis chapter 1, verse 26, he said, "Let us make man," Hebrew nase. That would seem to indicate that he used the matter he had created previously rather than creating new matter. So you read about that where he gathered up the dust of the earth and put it together into a human body. Then in Genesis 1:27, it says he created man. So even though he had in the previous verse made man from previously existing matter, this is back to a variant of bara. And in this context, he was creating the essence of humanity from nothing rather than from pre-existing material. So then in Exodus chapter 20, verse 11, God wrote with his own finger that in 6 days he made the heavens and the earth and the sea and all that in them is. In this case, it was the Hebrew word asa, which indicates that he used the material he had created previously. So first he brought matter and energy into existence, and then he worked with what he had done. He rearranged it, with the exception when it came to creating the spirit, the soul of man. He created that from scratch. So how did the universe get to its present state? First, there is no known natural explanation for how matter and energy could have come into existence. Second, the size of the universe, we'll talk about that somewhat in this episode. In later episodes, we're going to talk about the origin of the organization of the universe. Could a Big Bang produce the structure of the universe? And after a while, we'll get around to talking about the age of the universe. And then, is a Big Bang the most likely explanation for where the universe came from? So we would automatically predict, according to the concept of creation and evolution, certain things we should expect to find in nature. Creation says complex to simple. God started everything at its maximum complexity, most organized. So there should be a built-in tendency toward deterioration and disorder throughout nature, a tendency. Not instant, not always, but a tendency. Evolution, on the other hand, goes from simple to complex, supposedly. So since the universe has become more and more organized, there should be a built-in tendency toward increasing organization and order throughout nature. Those are our predictions. Well, what do we actually observe? We observe something called the second law of thermodynamics. thermo indicating heat, and all energy can change to heat. So the second law of thermodynamics says that energy expended in a closed or isolated system, that is, you don't have outside influences, that energy is going to move inexorably toward increasing entropy, disorganization. That is, the universe is deteriorating. This is not theoretical. This is observational. We've been watching this for several hundred years and seeing that, oh yeah, the universe really is deteriorating. It's going from complex to simple. That's really tough for evolution to account for. So speaking of the concept of entropy, which is disorganization or randomness, when it comes to energy, energy tends to flow from greater to lesser concentration. That is, it moves toward equilibrium with its surroundings. And as energy is used, more and more of it becomes randomly distributed as useless heat. It doesn't go out of existence, it just gets randomized and it's just spreading out through space. Now, when it comes to physical structure of matter, because matter is held together by stored chemical energy, it too tends to move toward random distribution and equilibrium with its surroundings. Information, this is an interesting concept. As structure breaks down and energy is lost in the form of random heat, the system's information content decreases. Information, that's the instructions that would be necessary to duplicate a system. So the more instructions it takes to reproduce a system, the more information it contains and the lower its entropy. As structure breaks down and energy is lost as random heat, entropy increases and information content decreases. You wouldn't expect something like an automobile, which is just parked outside for 100 years, to get more and more and more organized. We know practically things are going to decay, they're going to deteriorate. Information content has never been seen to increase by itself in either open, closed, or isolated systems. Open, anything, well, a lot of things can get out, get in and out. Closed, well, energy can get in and out. Isolated, nothing can get in and out. Let's think back to that word thermodynamics. It has to do with the flow of energy. I was challenged once when I was giving a talk to a group of university people to define what is energy. We don't have a good definition of energy. What we can do is say, well, energy is the ability to produce change. And I would always joke with my students and pull a bunch of coins out of my pocket and say, see, I'm like energy. But energy is just the ability to produce change. So can things happen by themselves? That would be a thermodynamically favorable reaction. Exothermic, which is pretty much a synonym for thermodynamically favorable, it would release more heat energy than it takes in. It can occur spontaneously in a closed or isolated system. For example, breaking down complex molecules such as DNA and proteins, burning oxygen, joining hydrogen and oxygen to form water, things like that. That's thermodynamically favorable. You don't have to really do anything. It'll go by itself. You might have to give it a little energy of activation, but generally it'll go pretty much by itself. Now, on the other hand, thermodynamically unfavorable reactions. These require more energy than they release, so we could say they're endothermic. They can occur in open systems, but they've never been seen spontaneously occurring in an isolated system. Energy's got to pay the cost. The universe has to pay for it. So some examples of thermodynamically unfavorable reactions would be formation of DNA and proteins, manufacture of gasoline, separation of water into hydrogen and oxygen, things like that. So when I say the formation of DNA and proteins, when something dies, the proteins are breaking down. This is something that's thermodynamically favorable, breaking them down, but putting together those things in the first place, no, that's unfavorable. That will only happen in the presence of something like DNA that's guiding the whole system. So what will happen to the universe? Entropy is a measure of disorganization, deterioration, randomness, what have you. So entropy tells us, or the second law of thermodynamics tells us, that entropy is continually increasing, steadily, inexorably flowing from greater to lesser concentration. For example, the potential energy in stars, the gravitational potential energy, the nuclear potential energy, it's converted to light, heat, other forms of radiation, and they spread out through space. Given enough time, all the stars will burn out. The universe will wind up being lifeless and cold, just a few degrees above absolute zero. It's a one-way process. I was giving a talk in China some years back, and I talked about thermodynamics. The students were raised as atheists, and I talked to them about thermodynamics, that the universe is deteriorating, it's falling apart. And one of the students raised his hand and said, well, what will happen to the universe? I said, it'll die. He said, what can we do about it? I said, absolutely nothing. There is no way human beings can stop the process of deterioration, of increasing entropy. Now, the only one that could stop that would be the one who made the universe in the first place. I believe God will fix the universe, but if you don't believe in God, if you're an atheist, you have no hope. So let's talk about those systems that are open systems. For instance, the Earth is an open system because we have energy coming in from the sun. A lot of evolutionists will tell us that, oh, entropy can decrease in open systems, things can spontaneously come together. Well, there are certain conditions necessary for entropy to decrease. Number one, there has to be a supply of energy coming from outside that system. So we've got a new developing human being, that's a system, got to be a supply of usable energy coming from outside. Well, okay, a bomb's got a great deal of energy. Let's set off a bomb next to a baby and see if it grows. No, it has to be a usable form of energy, the right kind of energy that the baby could use. It's got to be in the form of chemical energy in food. So it's got to be usable. And then there has to be some sort of a conversion mechanism to put the energy into a useful form. So if you pile up steaks and lobsters around a baby, the baby's going to starve to death because the baby's digestive system is not yet able to process the kind of foods that you're giving it. There has to be a conversion mechanism to put the energy into a useful form. And then you can give the baby all the energy you want, but it's not going to come together into a human body unless there's already pre-existing instructions, that is DNA, on how to use that energy properly. So I don't care how much energy is available. If there's no instruction plan, no DNA, there's going to be no growth. Now, this is where some people that are staunch believers in evolution really don't seem to understand. They'll say, well, things get orderly all the time. For instance, two hydrogens can come together and they'll form a water when you put them with oxygen, and then they'll come together and form ice crystals. Okay, crystals form not because of an increase in information, but an increase in order. For instance, water molecules always have a bent shape. We've confirmed this with X-ray crystallography for a long time. They have positive and negative ends. They're more or less a triangular shape, a bent shape. But as long as water is in the liquid or gas form, the molecules move too fast for that negative over by the oxygen to link up with the positive by the two hydrogens. They're moving too fast. But If you slow things down, that is, if you remove heat, where does the heat go? To the universe. So when enough heat is removed, then they'll slow down, link together, and form ice crystals. There's no more information in a molecule after it becomes part of a crystal than before it did. The only reason crystals are able to form is that the entropy of the use is increasing due to the heat released. So there's a chemical equation, delta G equals delta H minus T delta S, if you want to look that up in your chemistry books, where the Gibbs free energy is negative. There has to be energy released to the universe. Otherwise, it won't happen spontaneously. Well, what do you mean? This is all just random stuff. Okay, let's take a random arrangement of letters, as you see on the screen. I just took some letters, and you'll see which letters in a minute, but I just put them together randomly. What do they mean? Absolutely nothing. Well, okay, let's do what the evolutionists want. Let's make them orderly. Oh, yeah, look at that. Look how orderly it is. What does it mean? Absolutely nothing. There has to be not just order, but organization. Here's what happens when I organize those letters in a certain way. They say, "For God so loved the world that he gave his only begotten Son, that whosoever believeth in him should not perish but have everlasting life." It's the same letters, but there's a great deal of information contained in those letters now that wasn't there when I just put them in an orderly fashion. So if you want something to be alive, you don't randomly arrange the atoms and the molecules in alphabetical order. They have to contain information. So if I've got an open system, like a new little human body, and I want entropy to decrease, well, okay, first there has to be something coming in from outside. It's got to be a usable form. For instance, in a baby, it's got to be food energy, chemical energy in the food. Then there has to be some sort of a conversion mechanism to put the energy into a useful form. You need the baby's digestive system. Then there has to be pre-existing information in order to use the energy properly. DNA guides the way that the molecules are put together using the food energy. And then how's this going to happen? As entropy decreases in the open system, it has to increase by a greater amount at the source of the energy. There's always a cost. The universe has to pay for it. So you give a kid a hamburger, and he or she processes the hamburger meat to build together human structures. Yeah, but where did it come from? The hamburger meat came from a cow. How did the cow come together? Because it got chemical energy from the grass. How did the grass come together? It got chemical energy from the sun. It got radiant energy from the sun, converted it into chemical energy. So the sun paid for it. It doesn't happen spontaneously. It's got to have a payment. Entropy has to increase in the open system, bigger open system, by at least that amount. There's always a cost. So you might have heard of chaos theory. This says that, well, sure, things can become organized on their own. Well, there was even a Nobel Prize awarded regarding chaos theory, but it's only a mathematical model. It's never been observed in nature where things are going to come together and form spontaneous pockets of organization. It also deals with chaos only on a microscopic scale, and it's irrelevant to evolution because the local areas of organization in chaos theory are transient. Evolution requires areas of stability that are building on one another for billions and billions of years. The laws of thermodynamics have been established by centuries of observation, whereas things like the chaos theory is a relatively recent thing. Thermodynamics is observational, chaos is mathematical. It's basically mathematical modeling. It could be true, could not be true. But thermodynamics have to do with things that we could observe. We can see these things going on in the present using our observation, and then we apply inductive logic, finding the most likely explanation based on observation. Now, when it comes to the prehistoric past, as we're going to be discussing with the origin of the universe, Big Bang, and so forth, how many people have personal experience with having seen that? Nobody. No living person has personal experience. How about eyewitness accounts? Well, we do have one, the Bible, but that's unacceptable to skeptics. So how do we know about what happened in prehistoric times? Through deductive logic only if we reject the Bible as an authority. So let's think about logic. How do we know how things got the way they are out in space? Well, this is mainly deductive logic. It's based on presuppositions that we take as postulates. So the starting point for me would be, how big is everything? I'm sure you could start with other things, but let's consider that question. How big is everything? How do we know what's happening out in space? We humans have never gotten farther away than the moon, which is about 250,000 miles away from the Earth. It only takes light about 1.25 seconds to travel that distance. So we say it's 1.25 light seconds away. The farthest objects we've ever sent out are space probes that have left the solar system. Voyager 1 is supposed to be about 15.5 billion miles away. It's taken it 48 years to get that far. It takes light about 1.26 hours to travel that same distance. So cosmic distances are not usually represented in terms of light seconds or light hours, but light years. A light year is just under 6 trillion miles. That's about 400 times as far away as the Voyager probe is now. The nearest star, which is Proxima Centauri, is about 4.25 light years away. So our farthest probe has only traveled about 6/10,000ths of the distance to the nearest star, despite what you see on Star Trek and Star Wars. So when did humans begin to study science? We really don't have a record of it, but we can see in Genesis 1, verses 14 to 15, says the stars were given for signs and for seasons and for days and for years. Well, we don't know what the seasons were like between Adam and Noah, but the first mention we have of seed time and harvest, cold and heat, summer and winter, is Genesis 8:22, after the flood. So when you look at the sky at night and watch overnight or watch for a few hours, you'll see that the stars in the northern hemisphere seem to rotate counterclockwise every night. And over several months, the stars that are visible in the west will gradually drop below the horizon, and a different group of stars will become visible. And then some months later, the original stars will be back, and the stars that were there in between are gone. In the southern hemisphere, the situation is reversed. Rather than going counterclockwise, things seem to go clockwise. So by observing the stars, we can usually tell when it's time to plant and harvest, when the rivers are usually going to flood, and so forth. And we figured out with much effort that the apparent motion of the stars is because the Earth is turning. The ancient people connected the stars with imaginary lines. So we're in the United States most familiar with stuff like what the Greeks did, and the Romans built on the Greeks. Other parts of the world had different ideas, but they connected the stars with imaginary lines that would outline the images of animals, gods, and so on. So the familiar constellations, the group of stars that we have here, it's because somebody looked at it and said, oh yeah, look, it looks like there's a big leopard in the sky. It looks like there's a big bear in the sky. Somebody in other parts of the world with a different culture might have said, it looks like something or other else to me. But we use the ones from Greek and Roman mythology. So when they saw these lines in the sky, they made up all sorts of things, and they said, oh, look at that. That group Up there looks like it's a lion. That group looks like it's a dragon. That looks like it's a serpent. All of these things, well, they had no TV, so they were very imaginative, and they came up with their ideas for the stars, and we still use those names for most constellations. So throughout the Old Testament, there was a group, the Babylonians and Chaldeans, whose influence was extremely strong. They influenced astronomy, it's the study of the motion of the heavenly bodies, and also astrology, the belief that the heavenly bodies influence our lives, our personalities, events on Earth. There are still many people that look in the newspaper or look online every day for their daily horoscopes for guidance. Both of those, astronomy and astrology, can be traced back to the ancient Babylonians around the Tower of Babel, beginning with Nimrod. They kept very detailed records of the stars and the planets. So the Chaldeans were an elite group of Babylonian scholars. They continued to be influential long after the Babylonian Empire was conquered. They were present in the Persian court later with Daniel and also with Mordecai at the time of Esther. Mordecai was very influential. And so later, the Magi who visited Jesus, they were following the ancient Chaldean lore. They knew about it because of Esther and because of her cousin or uncle, whatever he was, Mordecai. But God made Abraham leave Ur of the Chaldees, so Chaldeans were a well-known group. They depended on the zodiac, so this is not really anything to do with creation or evolution, but I just wanted to give you a little idea about it. The signs of the zodiac are named according to the principal constellations in certain regions of the sky. So the Romans and the Greeks would look and see, what is the sun blocking out? So if you draw imaginary lines for the sun, up and down as well as left and right, the sun will block certain constellations at different times of the year. So the motion of the Earth around the sun makes it seem like the sun has moved to be in a different constellation. Oh, it's in Leo, it's in Virgo, it's in Capricorn, and so forth. So the ancient astrologers decided to divide the sky into 12 roughly equal parts. Of course, the Earth's axis wobbles very slightly, so NASA actually says we ought to divide it into 13 astrological signs instead of 12. But what does the Bible have to say about following astrology? It's condemned many places. The stars do not determine events on Earth. They're for signs and seasons, but they don't determine events on Earth. So some of the ancient Greeks gave us the ideas we have, or many of the ideas we have about astronomy and astrology. Even the names. Some of the heavenly bodies seem to occasionally move backwards as compared to the stars. They were called wanderers or planets by the Greeks. Then many of the Greeks believed that the Earth was the center of the universe. There were a small minority that didn't believe that. But one of the Greek ideas that came down to us was the planets and the stars were each attached to spheres. And when they rubbed against each other, they would make music of the spheres. All the stars and planets were supposed to be in orbit around the Earth. The most famous of the Greek philosophers was Aristotle, and his ideas passed to us because he taught Alexander the Great. He conquered the known world, that is, North Africa, West Asia, and a great deal of Europe, and that's where much of American culture has come from. So Aristotle taught some things such as, number one, the heavens are perfect and unchanging. Number two, since a sphere is a perfect shape, the heavenly bodies must be spheres. And he also taught that all the stars must be the same distance from the Earth. Well, we know better now because we've got a lot of authorities that have investigated it, but he didn't know. Here's why he reasoned that all the stars were the same distance from us. He believed the stars orbit the Earth. If there were different distances, there should be parallax between the nearer and the farther stars. What is parallax? Here's a little practice for you. Pick a light or something like that. A light is a good thing. and hold your thumb up at arm's length to block off that light. Close your right eye, left eye, right eye, left eye. The light will seem to be jumping back and forth. Or if you focus on the light, your thumb will seem to be jumping back and forth. Because of the fact that your thumb is at a different distance than the light, it seems to be moving back and forth. That's called parallax. So Aristotle reasoned that if the stars were different distances away, you should see some parallax between the nearer stars and the farther stars. He certainly could see parallax between the sun and the stars, but he couldn't see any parallax between any two stars. So he concluded there must not be any parallax. Therefore, all the stars must be the same distance away. Why did he get it wrong? His problem was that the stars were too far away to see parallax without a telescope. Didn't have telescopes. They weren't invented for a long time after him. So Aristotle started with an assumption, and remember, we've talked about this before, even if you use correct logical structure, a false premise can lead to false conclusions. So if I tell you all dogs bark, that is, if an animal is a dog, then it barks, and Snoopy is a dog, you have to conclude Snoopy barks. Snoopy barks. The problem is I've given you a false premise. Do all dogs really bark? No. There's an entire breed in Africa that don't bark, or Snoopy could have some individual problem. If any of our premises is wrong, then our conclusion is unreliable. Well, old Aristotle, he believed that if he could not see something, parallax or atoms, he also contradicted Democritus, poor guy, you couldn't stand up against Aristotle. So Aristotle believed if he couldn't see something, such as parallax or atoms, then it didn't exist. We've had something closer to our time. There was a thought process in the late 1800s. It led to the concept of vestigial organs. These are supposed to be left over from our distant evolutionary past. There were about 180 identified in the late 1800s, such as the tonsils, the appendix, the coccyx, the pineal gland, and so forth. Evolutionists didn't know what those structures did, so therefore, since we don't know what they do and we're so smart, they must not do anything. No, wrong. We've now learned the function of almost all of the supposed vestigial organs. Some would say we know what they all do. It's just that we didn't know. Aristotle, likewise, he couldn't see parallax, and so he said, well, all of the stars are at the same distance. If you've been following along on this podcast, The Bible and Science, you probably weren't expecting to get a history lesson today. But there's going to be a little bit more of this, and then we're going to jump back into the idea of the Big Bang and why I don't think that the Big Bang is a plausible thing at all.